So for the do now today, I just had you measure these angles, tell me if they were acute, right, or obtuse. So first, before we draw them, I want you guys to tell me what are the types of each angle that you got for each number. So we'll start with number 1, 25 degrees. What kind of angle is that? Acute. Perfect. How about number 2, 65 degrees? What kind is that? Also acute. Very good. Now we'll look at number 3. What's a 90-degree angle? A right angle. Perfect. And last but not least, 100. Yes, obtuse. Perfect, perfect, perfect. Okay, so let's go over constructing these. I'm going to label each one so I can put this on top of there. All right, so whenever we are constructing an angle, what is the first thing you do? Yeah, that's perfect. You want to start with that little point. Let me get my protractor. You're going to put a point on the little dot that's on your protractor, or you could just make a straight line to start with. Either way, we're always going to be starting with what we call a ray. So I have a tough time remembering to call this a ray and not a line, but we do remember that angles are made up of 2 rays, not lines. If they were lines, they would keep going on forever and ever. So we have our beginning point, and then let me actually get the protractor you guys are using so I can show you a little better. Okay, so where did you go from here once you had this drawn? Okay, so on this side or on this side?
This side.
Okay, that first side. And where should I be lining my protractor up with? Yeah, the dot. What's going to be our vertex? So I'm going to put that right on there. Make sure that the other end is lined up perfectly with the end of our arrow on our ray. And now we're counting from 0, 10, 20, 30, and between 20 and 30 right here would be our 25. So we want to be real precise with that and mark it right on that little tick mark. What'd you do from here? Just connect the dots like that. Okay. Perfect. Does your guys' 25-degree angle look about like this? Close enough? Good. Awesome. So I'm going to label that as 25 degrees, just like that. Okay. Let's try number 2, 65-degree angle. So we're going to do the same thing. Start with a straight line. Or sorry, a ray. Start with a ray. And I'll do the same thing you guys just told me. We're going to line the vertex, or what will be the vertex, up with that dot in the middle here, and the other end of my ray with 0 right there. Okay, and then where am I looking on this protractor for the little dot to connect the dots with to make my angle? Say it again.
Was number 65?
Number 65, yes.
So you're going to go from the same way we went up to the 65, which is going to be between the 60 and the 50.
Between the 60 and the 50.
No, between the 60 and the
Oh, yes, 60 and 70. Good, good. I know whenever we're opening up this way, it's really easy to mix up which direction to go, especially when you have numbers right in between 2 numbers. Because, you know, normally we count left to right. Yes. So I'm thinking like, oh, 60, there's 65, but that would actually be 55 since we're going backwards. So good job catching yourself on that. There is 60. There's 65 right up there. And I'll just connect my dots. And I'm not going to draw through my word. I'll just use that as a reference point and bring it down there. Just like that. Now, does that confuse either of you, seeing me not connect all the way to the dot?
No.
Okay, perfect. So we'll label this as 65 degrees. Perfect, perfect. Okay, how about number 3? We got 90 degrees. What is this one gonna look like? How could you describe it? Yeah, perfect up and down. It makes like the edge of a box or the edge of a square. So we'll start the same way with a ray going left to right there. Line it up and mark my 90 right here. Or you could even, they actually gave us a little hole to mark the 90 right there. And I'm just going to connect my dots. There. Okay, now what is the difference when we are labeling our angles? See how I drew little arcs before I wrote 65 degrees or 25 degrees? What do I do differently for a 90-degree angle? Yes, you're going to make a box inside. So anytime you see a right angle or you make a right angle, we don't want to draw an arc. We want to put a box at the inner corner, just like this. And that's going to tell us or indicate to us that this is a 90-degree angle. So anytime you see an angle and you're not able to measure it, if it's got that box in it, we automatically know it's 90 degrees. Perfect. Okay, last one, number 4. We've got an obtuse angle at 179 degrees. Now this one is a little weird, because it's going to be an extremely open angle. Do you guys remember talking about an angle that's 180 degrees yesterday? Okay, so what does that look like when it's 180 degrees? Yeah, it's just like a straight line going from here all the way to here. It's opened up completely flat. So 179 being super close to 180 is not going to look much different than a straight line. There's just going to be a little slight difference. So let's start with, right. It's going to look really similar to a straight line. So I'm going to line this up. Oh man, I'm in trouble here. I didn't make it long enough. Okay, let me extend this with like a pencil. I'm gonna do this. Okay, so I'll put this on here. And I'm gonna have to move my vertex over to here as well. All right, so 179, I'll zoom this in just a little bit. Whenever we are looking at the angle that's opening from here, going up from 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, all the way over to 170 right here, we're going all the way, not quite to 180, but that one point right before it. Let me make that as accurate as I can. About right there. Pretty close. So, because I messed up, I'm going to have to make sure I connect it to the right point that I made. And we're going to connect our dots as best as we can. So, that is looking pretty close to a straight line. I did not do that perfectly at all, by any means. It shouldn't be an exactly perfect straight line. It should just be pretty close to a straight line. So I didn't give you guys the best depiction there. Maybe I should do that again, make it look a little better. I am going to do it again. Let's make sure that we know what that looks like. So I'm going to start again, give myself a ray with a vertex, line it up real good. And I'm going to mark my point again, right about here. Okay, we're going to try a second time. Man, I'll tell you what, that is just so crazy looking. 179 is really tough to do. Yeah, it's going to look pretty darn close to a straight line, guys. Is your paper looking kind of like this? Pretty close? All right, good deal. Okay, do we have any questions about constructing those angles and categorizing them as acute, right, or obtuse? Or you guys feel pretty okay about that?
The only question I have for the obtuse one, when we put our little circle for the degree, is it
Yes.
still going right in the middle?
Yes, so I'm glad you mentioned that. I forgot to label it. So on our obtuse angle, we would do the same thing. This time it's going to look almost like a half circle. And that arc just shows us where the angle is opening from. So we'll name this 179 degrees. There we go. Okay. So, guys, today we are learning something new, and I'm actually super excited about it. This was always my personal favorite part of geometry. But before we get to that new part, I need to give you a new vocabulary word. So if you like to keep notes, we're going to give you another definition. So I'm going to write up here, Unit 1 continued. Just so that we know that these are continued, that these are part of the Unit 1 notes. And I'm going to title this Constructions, just like that. Okay, and if either of you need paper or, well, it looks like you guys got stuff, that's good. So before we actually do constructions, like I said, we need to make sure that we understand some of the words we're going to use to describe them. So the first word I'm going to have you write is perpendicular. Perpendicular. Have either of you heard that word before, perpendicular? Yeah, it should sound a little familiar. Do you guys know what perpendicular means? Straight up and down? Yeah. So whenever we're referring to perpendicular, we are referring to lines or line segments that are crossing over each other or intersecting at a very specific angle. So to draw a picture of perpendicular, I'm going to start by making a line that goes straight up and down. And this one doesn't have to be 100% accurate. We can just kind of make a reference picture here. And once you've done the straight up and down line, we want to also put a line straight left to right, just like this. Now, whenever we have a line going straight up and down and a line going straight left to right, what do you guys think the measure of these angles that these lines are creating, what do you think that is going to be the measure here? How many degrees? 90 degrees, exactly. So we know that whenever we have lines that are perpendicular, they intersect at a perfect 90 degrees every time. So to define this, I'm going to say lines that intersect at a perfect 90-degree angle. Okay. So if we ever see that lines have a right angle or a 90-degree angle, we know that they are perpendicular. And this right angle is going to go for every single angle where they are intersecting. So we could even draw that box on all the other 3 angles as well. Okay, the next word that we need to talk about is parallel. You guys heard that word too?
Parallel parking.
Yeah, parallel parking. Love it. So parallel lines are a little different. And I'm going to draw an example of them for you. If we have one line going like this, for the other line to be parallel, it needs to be going at the exact same angle, and those lines will never touch. If they are parallel, they will never ever touch each other. So the way that we indicate or label lines as being parallel is we will put another little arrow on both of them, just like that. So when we see this symbol, that tells us the lines are parallel. They will never cross. They're always going to go at the same angle. So for my definition, I'll say lines that never intersect. And do you guys know what I mean when I say intersect? Okay, good deal. Just like an intersection at like a 4-way stop or something. Okay, and once we've got that written down, there's just one more. And I'm going to put this one over to the side here. We are going to be using this word a bunch today. Bisect. Bisect. Have either of you heard that word before? Okay, so yes and no. So bisect, Selena, if you've heard it, do you maybe remember what it means? Just familiar with it? I gotcha. So to bisect something is to cut it in half. Whenever you bisect, you cut it in half. So I'm going to say to the definition of bisect, let's say to split, wow, I can't spell, to split in half. Yeah. So whenever we say bisect, so first of all, that prefix bi means two. So dissect is like splitting up into a bunch of parts. Bisect is splitting up into 2 parts, exactly. So to split in half, and I'll put in parentheses here, 2 equal parts. Okay, so once we've got that written down, these are the only 3 kind of vocab words that we need today. And we are going to learn how to use this today, a compass. Yeah, I know, I love using these, they're so fun. So I have some for you guys, right over here. And they have never been used. So they're like still in the plastic wrap. So you guys get to open them up. So I'm going to give you both of these, and you can pass one back to Selena. Thank you. And go ahead and get those opened up, and we are going to learn how to do some constructions today.
Is that all of our notes?
For now, we might do a little more on here. I would say you can put it to the side for now, though. And we're going to start on a fresh sheet of paper next. And we're just going to practice using these compasses. Okay, so now that you guys have your compasses, first of all, you're going to notice they are like really stiff. So we might want to kind of loosen them up a little bit since they're brand new. It's good that they're stiff because they'll hold their position pretty well, but we don't want to not be able to open them up to a certain point. Okay, so have either of you used one of these before? Okay, yeah, a long time ago. So I like to think of a compass as like a circle maker. Basically, this little point, first of all, it is so sharp. They got me some really sharp ones. We use this as the middle of the circle, and we place it on a certain point, and whatever distance our pencil is away from that point, we are going to be able to get a circle with this radius as the length. So the radius is just half the length of a circle. So we take it like this, and I personally prefer to move my paper over moving the pencil, and I just do this. And it is going to make you a perfect circle every single time, just like that. So you guys go ahead and try that. See if you can make yourself a couple perfect circles on your paper. Just play around with it for a minute. We could also mark that little midpoint here, the center of our circle. Now, do you guys remember what we talked about yesterday at all? How many degrees a circle is? We only talked about it for like 30 seconds, so it's okay if you don't remember.
I never heard him say it.
Okay, here, I'll show you. I'm going to draw a line, and we're going to measure it. Once you get a circle, we'll measure. Okay, so I want you guys, once you've drawn a circle, draw a ray coming right out of the middle of it, just like this. Yeah, there we go. Awesome. Okay, so if we were to classify this as an angle, remember an angle is made up of two rays. Now, this might not look like an angle because it looks like there's only one ray here. But what if I told you that in a circle, the rays, the two rays that make up the circle, are right on top of each other? So here's what happens. If I wanted to measure this, I put it on here. If this is my starting point and my ending point, I would be going all the way around to 180, and then it would go all the way around again. I'm going to turn that around. So my angle has moved all the way here to 180, and then it's going to go a whole nother 180 back to that starting point. So if I were to add, and you guys can use your calculators if you need to, 180 degrees plus another full 180 degrees, how many degrees is that going to give me? 360. So guys, a circle is just a 360 degree angle. As crazy as that looks, that's how we would label it. It's a 360 degree angle. So just like whenever we labeled our other angles, if you notice, we would put that little arc on the inside. So remember that as we are drawing our angles and labeling them, that little arc on the inside is just the part of the circle. It's just showing us how much of the circle this is opened up. So if we were to keep going and bring this line over, all the way through, that's how we get to that circle. A full 360 degrees makes that circle. So kind of cool. I think it's interesting. Okay, so we can make circles with our compasses. I'm going to teach you our first construction. And let me think. I think a fresh page would be good for this so that we can kind of write some notes specifically about this construction. So I would like for you to title your page, and we're going to call this page Perpendicular Bisector. Perpendicular bisector. Oh my goodness, that is blurry. There we go. I'm going to say how to construct. Okay. So, first of all, we need to know what a perpendicular bisector is in order to be able to make one. So, I am going to show you that real quick. Basically, a perpendicular bisector, the way I'm going to show you is I'm going to start by drawing a line that measures to be about 3 inches exactly. So I want that to be 3 inches. So if my line is 3 inches, where would the very middle of my line be? What's the midpoint of 3? What's half of 3? Almost 2. So 2 would be 2/3 of 3. What if I took 3 and split it in half? So 2.5 is right here. Is this the middle of my line? You're so close. I know which way you're trying to go.
Half the 3 is 150 and 150. So right in the middle of the 1.
Yeah, right between 1 and 2 at 1.5. 1.5. That's going to be our middle. So if I were to put a little mark there, I have now bisected this line. I've split it in half equally. And here's how I want to show that this is equal on both sides. We always label what we call congruency. We'll talk a little more about that later. But to show that two things are the same length, we put little marks like this. So because I put these two little dashes on each side, that tells me both of these sides are equal. They're the same. So my line has been bisected. It has been split in half. But the next step is making it a perpendicular bisector. So what I want is to have a line that splits this original line perfectly in half, and it is intersecting with the original line at a perfect 90-degree angle. So here's where we could use our protractor. I'm going to flip mine upside down because I don't have enough room on my page. And I also don't have long enough lines to make this perfect, but I'm gonna kind of guess on here because this line lines up with my blue lines, so that's what I'm gonna use. Okay, and here's 90, or here, and we are going to line that up and draw a line that goes through that midpoint that we marked, like this. Now, we don't have to necessarily be bisecting the line we just drew. This line just has to be bisecting our original line. So because we know that we put this second line at a 90-degree angle to the first line, how can we label that? No, you're okay. So if I have just made a line that is intersecting the original line at 90 degrees exactly at a right angle, what could I do to show you visually that this is a 90-degree angle? Yeah, put the little square or the little box inside. And you really only need to do it to one. You could do it to all four if you wanted to. So this is what a perpendicular bisector will look like. But I'm going to teach you how to do it without a protractor. So that's what it'll look like. It's going to be crossing at a 90-degree angle, and we're going to be splitting it in half perfectly. So I would like for you a little lower on your page to draw a line again. And this time, let's make it about 3.5 inches, just slightly larger. And then we're going to put the ruler to the side for a minute. So here is step one. Once you've drawn your line, I'll let everybody get to that point. So if I take my compass, I want to open it up so that the angle it's opening at is matching the length of this line perfectly. So I'm going to open it, and get it to where it's touching those end points perfectly, just like this. I'll zoom out a little so we can see that. Good. Okay, once you've got that length, this is where it's kind of nice that these are stiff because we don't want to change this opening anymore. We're going to use that and we're going to draw arcs just like this. We're going to go from here up, and I drew my line too high. It's going to go through my words. And then we're going to do the same thing on the other side. Flip it around, line it up as best you can, and make another arc. And you want your arcs to create an intersection above your line, just like that. And if either of you need help with this, let me know. I'm more than happy to go over it and show you. So protractor matches the length of your line. Make an arc going up and over. Other end, arc going up and over. Make sure they cross in the middle. You guys got that so far? Okay, so now what we do, I'll zoom out even more, is we are going to do the same thing but on the bottom. So I want to line it up again real good and make my arc, and the same thing on the other side. Oops, hang on, I accidentally made that little. Okay. Okay, so whenever you've got that done, you should have an intersection on top of your line and an intersection below your line. So here's what we do now. This is where we're going to bring the ruler back. And we want to line the ruler up with those intersections that we just created, just like this. You want to be real precise with it. And then we're going to trace a line that goes through those intersections we made. Okay. Once you got that, looky there, we made a perpendicular bisector. So whenever we use these arcs, what's happening is as we pull the edge of that circle, over here from this side and do the same thing on the other, that intersection on the top and the bottom is going to line up perfectly with the midpoint of our original line. And it's going to be crossing at that perfect 90-degree angle. So there's our perpendicular bisector. And I'll just call that So to label that this is a bisector, we want to do the same thing we did on that first example. We've got our box to show it's 90 degrees, and then we want to put the 2 dashes on either side of that original line to show that it is perfectly bisected, cut in half. All right. So we're going to do a bunch of practice with that. Once you've got all that labeled, let's do it again, but this time let's make a 2-inch line. One, two. And I'll walk you through the steps again. So once you've got your line, this time we are going to take our compass again and pick one of the end points to start with and open it up until our pencil is perfectly touching the other end of the line. Oh my goodness, I just bent mine. Okay. Here we go. That's pretty good. So once we've got it lined up, we want to create a little arc going one way, then turn it around and do it the other way. Just like that. For the bottom too, absolutely. And we'll do that same thing underneath. Just like that. And once you've got all your little arcs drawn, we are going to connect those intersections again. Just like this. And it's going to work every time. You're always going to get a perfect 90-degree angle. It's always going to cut your line perfectly in half, no matter what length it is. So this is a great way to also find your midpoint. That midpoint is just the point in the middle of the line. So once you've got that perpendicular bisector drawn, make sure that we also label it by putting a box inside and marking the equal sides like this. We always want to finish it like that. Good deal. And we could also check our work using our ruler. So if my line is 2 inches long, that bisector should line up perfectly on the 1-inch mark, which it does. It looks perfect. All right. You guys got that? Oh, okay, so yours is looking big because you're drawing the whole circles, and that's fine. Yeah, I'm going to show on this video what you're doing because that is totally the right way to do it. It's just you're adding extra steps that you don't necessarily need. So let me show you. Let's do, I'll do another 2-inch line. I'll do 3 and put it right in the middle of my paper. Okay, so 1, 2, 3. And this time I'm just gonna put points on it. Okay, so what you are doing, it looks like, oh, and this is gonna go off my page. I already know it. We're lining it up with our end points, and you are drawing your circle like this and going all the way around like that. And I lost my shape a little. I'll make sure that lines up right. Let's see. Okay, there we go. So you've made one circle there. And on the other side, you made another circle. That's not gonna fit on my page. So this is perfect for getting your answer, absolutely. You're still gonna be using these little intersections that you've created. The only reason I didn't draw the whole circle was because I know that I don't need that part of the circle. So we're just using where the circles overlap and intersect right here. So if anything, I actually don't even need to draw it all the way down to here. I could just get that little X mark here. Now if you do draw the whole circle, or if you do draw the whole arc, that's still correct. I'm not ever going to mark you wrong for that, as long as you're getting the right angle. But I know whenever I was taught in school, they always told us to just do it like this. We would hold it up to the length, and they would say to mark one line here and mark one line here, and that's where it would cross through. Now you could absolutely do it that way. I just think sometimes it does help to see the whole picture of where those lines came from. So really they're coming from these two circles. It's just these intersections here. Does that make sense? Good deal. Awesome, awesome. Okay, so I am gonna give you a couple of lengths of lines that I want you to draw, and I'm gonna have you construct the perpendicular bisectors yourselves, and then I'm gonna come and check them and see how we did. So I'm gonna just give you 2 for now. First, let's do a line that is 2 1/4 inches long. I'm going to say make the perpendicular bisector. And same for a 3 let's do 3 3/8 inches, making you guys think about those measurements again. I know it. Okay, perpendicular bisector. Okay. So you guys get working on those. Here, I'll zoom in so you can see that better. And I'll pause the recording, and I'll be around in case you need help. Here. All right, so you guys did them perfectly. Perfectly. So I am actually gonna go through the process one more time just to really stick it in our brains. Make sure that yours is looking exactly like mine, which from what I just saw, it looks like they are pretty exact. So we had a line that's 2 1/4 inches. So I'm gonna start here and go past 2, and here is my first 1/16, 1/8, 3/16, 1/4, right there. I'll just connect those. Okay. And then it looks like you guys did this part correctly too. We'll just connect to one end, get our pencil to line up with the other. It's perfect as we can. And draw the arc there, and draw the arc there. You could do it that way. And same thing on the other side. We're gonna put one. Oof, my goodness. I know, it is tricky to hold these right. My hand wants to start twitching. And I got one here. Oh my Lord. And one here. There we go. Then we just connect those little points. Now, did you guys label yours as well?
I put the little square.
The square? Okay, so what's the other thing we need to do to show that we split that original line in half? Yes, we want to put our congruency symbols. We'll talk more about that later still. But this is showing that our lines are equal on both sides. We split it in half perfectly. So there we go, that's number one. Perfect, perfect. And number two, we have 3 3/8 of an inch. I think I can fit it right next to it. So I've got 3 inches, and let me look at my cheat sheet. 3/8. Where is that? Okay, it's 2 below a half. So here's a half, 1, 2. There's my 3/8. All right. We're going to bisect that one. So we'll adjust our compass. Make our arcs. Same thing below. Alright, we just gotta connect those. And whenever I was looking at your papers, again, you guys, it looks like yours were pretty identical to this. So that is perfect. There we go. And we'll label it with the 90-degree square and our congruency lines. There we go. Okay, I would have loved to show you one more type of construction, but we've got about, let's see, it's 10:18. Oh, we still have time. Okay, I was thinking we got done a lot sooner than that. Never mind. We're gonna do one more. So, we just did a perpendicular bisector. Now, we're gonna do one more. This is an angle bisector. We're gonna cut an angle in half. So, here's how we do that. I'm gonna label this angle bisector. And I am going to start by making, let's do a 60-degree angle. So I'm going to have you guys do that same thing. I'm going to make my ray on the bottom. Let's see, how many inches does it need to be? Let's make it 3 inches. That way it'll line up with our protractor. So here is the bottom. And we're going to line it up, and I want you, like I said, make a 60-degree angle. So I'll go up to 60. And are we using the inside numbers or the outside numbers? Inside, good. So here's where 60 is, right there. And I'm going to connect my dots. Okay, perfect. I'll let you guys get that ready. I'm going to pull something up real quick. Oops. Okay. And I'm going to post I'm about to pull up a little cheat sheet. I'll post this on Google Classroom today as well, if I can find it. Okay, I'm going to pause that real quick. So, first thing we need to do is use our compass and put it on our vertex like this. Let me zoom out a little. Now we want to create an arc on here, and the rule with our first arc that we create is we need it to be smaller than half of the length of our rays. So it's not going to work if we make it like a really big arc out here. We just want to make it a real little one. So I always, to be safe, just make it much less than half. So I'm going to do it like right here. Oh my goodness, I keep bending this. You see that? I must be pushing way too hard. Okay, I'm going to turn my page. Just like that. Okay, so step one, done. We got a little arc on there. Now, step two, we want to take this protractor, or not protractor, this compass, and we want to line it up now with the intersection we just made right here, and we want our pencil to line up with our vertex like this, because we're trying to make sure that this is the length of wherever our vertex is to the arc we just created. I'm going to take this and make a little arc on the inside of my angle here. Just like that. So here's what I did again. I measured to see what this length was. So really your protractor is going to stay at, I keep saying that. Your compass is going to stay at the same opening distance from where you made that first arc. All right? Then you're going to take that length or that opening where it is, move it to here, and make another arc just like that. Okay? Now keep this at the same distance of opening and put it on this point and make another arc like that. So first we made this arc, then we moved up to here and made this arc, then we went to here where we made another intersection and we made a third arc right there. You see that? And then we just connect from here to this intersection that we created. And our angle is split in half. We bisected it. Just like that. Kind of cool. Now, we'll work on this more tomorrow. I'm keeping you guys too long. It is 10:26. I am going to have an exit ticket for you today. You don't have to turn it in today. We've got a whole week to do it. And I'm going to have it posted on Google Classroom. But it's going to be just these perpendicular bisectors. So I'm going to have you construct the perpendicular bisector of a 1-inch line and a 2-inch line. Yes. If you guys, and again, we have a whole week to turn it in. If you want to just wait till tomorrow to work on it, you're welcome to do it during the do now time. So don't worry about doing it right now, but this will be the exit ticket for day 3. I'll have it all posted on Google tonight. So, all right, you guys are free. I don't mean to hold you hostage.